All right, team. So today, oh, attack dogs. Oh, that's rough. All right, today we are going to take a look at the first part of the lesson involving reasoning arguments and proofs. So we're going to try to distinguish between formal and informal types of proofs, which we'll talk about in just a moment. You want to understand the difference between inductive and deductive reasoning, and you want to draw some conclusions based on formal and informal reasoning. Okay? So, in order to really get into the meat of the lesson here, I'm going to turn my camera off and you all can come with me on the journey. Okay? So, let's play a game, everybody. How many fingers are pointing? Go ahead and put your answer in the chat. Yes, in many different languages, we have one finger. Okay? No, okay, how about now? How many fingers are pointing now? 5 is incorrect. The correct response is 2. Dose is also acceptable. No, Caleb. 2. 2. All right. How about now? How many fingers do you see now? 3, right? Okay. So, okay, how many fingers are going to be on the next slide? Okay. You never know. I see a lot of wild and crazy answers. But given what we've done so far, what do you think? How many do you think are going to be there? Okay. Right? The obvious answer is 4. So, congratulations, everybody. You all just used inductive logic. Okay? You used inductive logic. You took a look at what you saw. You saw 1 finger, 2 fingers, and then 3 fingers, and you figured, using your observation and what had just happened, that obviously there'd be 4 fingers on the next slide. You used your common sense. This time, you were mistaken. However, inductive reasoning isn't usually a bad way to go about doing things, is it? I mean, it can certainly work. We have people using inductive logic all the time. So, given this information, in your own words, can you put a definition of inductive reasoning in the chat? And while you're doing that, I'm going to send you the notes pages. Okay, common knowledge, common sense. Seeing some good things here so far. Okay, so what you're going to do with these definitions that you have written down here, okay, I'm going to send you the notes pages. The first question is, write down your own definition of inductive reasoning on your notes page, okay? Now, you can either copy and paste it in, or you can type it in yourself. But I would like to definitely make sure that you have a definition in your own words for inductive reasoning in the notes pages, because that is on the quiz, but also because it's going to be a big part of what we're doing, okay? So, notes page is incoming. Oh, wow. All right, TR later. Okay. Now, while you are writing down your notes on your notes page, good job, by the way, for doing that. Thank you. Can you use your whiteboard tools and put in this section, what does the word observation mean in the sentences above? Okay. Observation is in both of these definitions. We have observation here. We used observation, past experiences to make an educated guess, and we have specific observations as a way to draw inductive logical assumptions. So, using your whiteboard tools, can you say what inductive or what observation means in the sentences above? Let's see, how about we have some volunteers here. How about we have Kaylee, London, Micaiah, Mariah, and Michael. Go ahead and see if you can give that a shot. If you want to play as well, feel free. But looking for Michael, Mariah, Micaiah, London, and Kaylee. Go ahead and try to put a definition for observation on the board. Yes, but I mean, if you want to answer, that's fine too. It's just like in school. If I call on you and someone else answers, I guess you just got off the hook, but I still want you to answer it too. Okay? So we will be calling on folks. So stick by your computer. You never know when your stick's going to get called. You can still answer, Ethan. It's okay. That's the magic. I mean, you can answer in the board. You can answer in private chat. You can definitely still participate if I don't call on you. That's totally okay. Yeah, I see that. You did. Okay, so we've got what you know from what you saw. If you look at something, you remember what it is the next time it comes up. Looking at what you saw before. Okay, the idea of observation, meaning something you see, something you notice, something you look at. Oh, thank you, Michael. All right, good man. Okay, looking at a situation that's occurring. Okay, all of these are good definitions for the idea of observation. So, using inductive logic is based on something you see or something you felt, something that's happened to you. Okay? Deductive logic works a little differently. Okay? Deductive logic involves using previously proven or accepted properties in order to reach conclusions. Put another way, you have valid premises plus solid arguments, and that equals deductive reasoning. Okay? So this is kind of a mouthful. So we're going to kind of break this down a little bit. Yep, you're right, Ethan. So let's get at this a little differently. Okay? We have to start off with a premise. Okay? And premise starts off all of our deductive logic answers and proofs. Okay? And a premise is a statement that we presume to be true in the course of a logical argument. Okay? It's what you start out with. The premise is the statement at the start. Okay? So, think about the game we just played, right? I said, count the fingers on the screen. You know, we went through, different fingers are pointing. Okay, what was the premise of the game? This time we'll call on our dear friend Team D. Corey, Dakota, Dawson, Dominic, Dylan, and Ethan. What's the premise of the game? You can use your whiteboard tools, or you can put it in the chat. Okay, so Ethan tells us there's one finger at a time. I see in the chat the premise of the game involved counting the pointing fingers, right? So what we started with was count these fingers. Okay, so that's our premise. This right here that Andrew put on the board, this would be an example of the entire statement, right? This is the whole inductive logic statement. The premise is just the beginning. Okay? So just what happens at the start is the premise. The premise is the statement you start out with. Okay? But I really like this, and we're definitely going to come back to this slide because we're going to use this, I think, as our proof to talk about the other ones too. So, premises at the beginning of our statement. There are two types of premises, okay? There are valid premises and invalid. Okay? And like you would think, a valid premise is one that is true, correct? And an invalid premise is one that is false. Okay? Can anybody give me an example of a valid premise? Something that you know is true, otherwise known as a postulate, like we talked about a couple weeks ago. Tacos are amazing. You know what? Sky is blue on sunny days. I will take that. I'm 16 years old. No proof needed. Tacos are amazing. Mic drop. Bacon is better. So the point here is that a premise is, again, it's like a postulate. It's a statement that you can't argue with. It's what we start off with. Okay? Tomatoes are red. I'm 16. These are all examples of premises. Okay? And these could start out our logical statements. Bananas are yellow. So we have our premise. Then we need to go to our logical argument, right? Because we have these great premises, but we need a little more. We can't just have a premise. We need to have an argument next. So take a look here. Okay? We're going to go into geometry for a moment. Given this, that CX is a perpendicular bisector of AB, does AC equal AD? Is this yellow line and this blue line, are these two things equal? Okay. How do you know? Okay, Corey says eyes. Tell me more. What about your eyes? Okay, so you looked at it and you could tell? Okay, you made an observation? Okay, so now, this is going to be something that's going to frustrate some people about math. Okay, everyone who said that they're equal, you're absolutely right. Okay, the lines are equal. But what is that? What is that beautiful stuff in the chat? because CX is the perpendicular bisector and a bisector is a line that splits something into two equal parts, that would be an example of this is a wonderful example of a logical deduction. Okay? That is really nice. What he did was, he did more than just say, because you saw it, right? He took it to the next step, and he put in information from geometry, postulates, already proven theories, to support his argument in a logical way. Here's the key. You're all right that these two lines are equal, but it's not whether you know it's true or not. This is all about if you can prove it. Okay? There's a classic line from the movie Training Day, which is one of my favorites, which might be a little old for you all, but it's not what you know, it's what you can prove. That's what this whole unit is about. It's not what you know, it's what you can prove. So, in that spirit, okay, a proof, and again, if you are writing down definitions, this would be the time to write down the definition of the word proof. Okay? A proof is a clear logical structure of reasoning that begins from accepted ideas, proceeds through logic to reach a conclusion. Okay? So, there's three parts here. Okay? A logical structure of reasoning that begins from an accepted idea. Okay? So, that's what we called our premise, right? Our premise is our accepted idea. Okay? Then it proceeds through logic. So this was the difference between saying I can see that they're even, and they're even because bisectors split lines into two equal parts, and because lines are split into two equal parts, the line segments are equal, so the lines that they draw up to the top of the triangle are equal. That is all logical proof. Now, we aren't going to get into actually proving things yet. That we're going to do later on. But you have to get used to the idea of using logic. Okay? And last but not least, we have our conclusion, right? Again, the conclusion is you might already know the conclusion, right? You all already knew that these two lines were equal. You knew it. You all said yes, you could see it. You may, oftentimes in geometry, you might know the answer and you might even know the question. The hard part is finding the stuff that goes in the middle. Okay? That's where the most of the work in this section is going to happen. Green check if you're still with me. Red X if you're confused or have questions. Don't put them in yet. Okay, put them in now. Okay, if you have a red X by your name, Miss Ward or myself are going to send you a private chat. So hang tight. If you don't, we are going to keep moving. So, like we mentioned, the conclusion's the answer you come up with after proving your argument with logic. Okay? So, again, put another way, it's what you get at the end of your proof. Okay? Oh, thank you, Ethan. Good looking out. So, let's get a blank page here. Okay? See if y'all can help me out. Shakoya, Sheridan, Stephen, Taylor, and some of the Tylers. Okay? Can you tell me what a premise is? Go ahead and put it on the board. You could be pulling this information from your notes. That would be awesome. You could be pulling it from a previous slide. I will go ahead and click the unfollow button so you can go check it out. Okay? But again, Tyler's, Taylor, Stephen, Sheridan, Shakoya. What is a premise? Yes, Shakoya, there you go. Chris is in there. It's what you start with, okay? It's at the beginning, okay? Okay? So since we did kind of near the end of the alphabet for premise, let's go to the start of the alphabet for the conclusion. Alyssa, Andrew, Ben, Brendan, Brianna, what is a conclusion? Okay, Andrew's in there speaking for the A's and B's. Okay, and the logic is what goes in the middle of our proof sandwich. Okay, again, tomorrow we're going to spend a lot of time talking about what exactly goes in the middle, how we know something is real or fake, valid or invalid. So, now let's go back to where we started. Okay? Remember, Andrew so kindly wrote down our whole argument down here. Okay? There was one finger, then two fingers, then three fingers, then poop. Okay? Is this valid or invalid? Wait, okay. I'm confused. Because you all told me that what would make sense would be if there were four fingers. Now you're telling me it's valid that it was poop. It can't be both. So which is more valid? One finger, two finger, three finger, four finger? Or one finger, two finger, three finger poop? Which is more valid? Ah, see, there's some confusion here, isn't there? There's a difference between what was actually there and what should have been there. And that is the crux of what we're talking about, okay? If you have, yeah, it didn't follow the sequence. It didn't make sense. Our premise was count the fingers, okay? The conclusion was poop. The conclusion did not match the premise. And so the whole statement is invalid, okay? When you all used your inductive reasoning to correctly figure there should have been 4 fingers on the next slide. That would have been that would have made sense. If you have 3 fingers and then poop, that doesn't make any sense. So although poop is pretty cool and pretty funny, there should have been 4 fingers on the slide. So when you're working these problems, okay, you want to remember, you want to think about what should be there using your deductive logic skills. Okay? So let's take a look at some examples from math now. Okay? I'm going to give you your whiteboard tools. Can you, let's see, Catherine, Chelsea, Cheyenne, Christopher, and Christine and Corey, all the C's, can you all highlight the premise in this mathematical problem using your highlighting tool? Give it a shot, Corey. I mean, no, it's just going to be a color on the board. No one will know it's you but me and Miss Ward. Okay, feel free to use many different colors. If you go down, if you click on the tool with the highlighter, you can change your color. It'd be nice because then we can tell who's got it and who might need another look at it. Oh, I like that, making a circle by it. That'll work too. Yeah, it does. You're right. Okay? Okay, remember, premise is always at the okay, the premise is always at the beginning. So we're going to use all these friendly highlighting tools. Thanks. Boop, 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 boop. Okay, the premise is always at the beginning. Okay, got to remember that. It even tells you over here, true premise is at the beginning. Okay, now we'll call on the middle of the alphabet here for a middle question. Gerald, Haneen, Jaden, Jasmine, Jason, and Jenna and Juan. Where is the deductive reasoning? Is it in the middle or is it at the end? Where is the deductive reasoning? Very nice, Jaden and Haneen, very nice. Mr. England, very good. Okay. Thank you, Jasmine. Okay, so our deductive reasoning is in the middle. Okay, if we were doing inductive reasoning, it would also be in the middle. And last but not least, pun intended, Sarah, Ronald, Paige, Nicole, where is the conclusion? Use your highlighted tools to highlight the conclusion. Very nice, Sarah. Oh, that pointer went away. I wonder who it was. It's going to give him some props. Oh, it's back. I can't even click on it. I don't know. Thumbs up to whoever's pointing at it correctly. I don't know who you are, but you're doing it. Thanks, Paige. Very nice. That's Bell's in the building. Okay, so, oh, thanks, Ethan. So, okay, these three things, where the premise is, where deductive reasoning is, and where the conclusion is, are going to be questions on your quiz. So, make sure you know them, make sure you love them, make sure you realize where they are. Here's a harder question, okay? What is the difference between inductive reasoning and deductive reasoning? Okay? If you think you know, go ahead and give it a shot. I'm not going to call on anybody for this one. Just go ahead and put an answer in the chat or on the board if you think you have an idea or you want to take a stab at it. Feeling brave today. The difference between inductive reasoning and deductive reasoning. Sending the notes page out again. This is a friendly reminder. You definitely want to be writing this stuff down. So I sent the note page out again for those of you who might have shown up a little late. Please take the note page, download it, and write in it. It is for you. No, Christopher, you got it. Deductive is something that you prove logically. Yes. Okay? If deductive reasoning is something you prove logically, with a series of steps, and what's inductive reasoning then? Okay, deductive uses already proven things to reach the end, and inductive uses your own observation and experience to make a guess. Very nice, Dakota. Inductive reasoning is your observations and experiences. Okay, now I'm going to break Corey's heart. Corey, the statement, tacos are awesome. If you're proving that, would you have to prove it using inductive or deductive reasoning? Well, Ethan, would it? Yeah, because it's your own idea. Just like with this bacon, okay? Even if you're using bacon, it's your experience of bacon, right? There's no bacon proof. There's no, law of bacon, except Bacon's law, which is not beside the point. The point here is, it's your experience and your observations that make bacon and or tacos awesome. Therefore, you'd have to use inductive reasoning to get there. However, if you have logical proof, then you have deductive reasoning. Okay. Any questions about any of this awesome stuff we're going over right now? Please put them in a public or private chat if you have questions. I'm going to give you all a minute. I'm going to open up the slides for you to reflect on what we've done. So I'm just going to give you all a minute. Talk amongst yourselves. See if it makes sense. Figure out, see if you have any questions about it. Go ahead and take a look through the slides And in about a minute or two, I will have you all come back and we'll take the quiz, okay? If you need to write something down, this would be a good time to do it. If you need more time, let me know. If you're just chatting in the chat, I hope that means you have notes. We are going to take a brief quiz on this in a minute and 30 seconds, maybe like 2 minutes total. If you need more time, again, please let me know. All right. Any idea? Any questions? We nailed it. We're good. No? All right. Hey, how much time do people need more time? Green check if you do, red X if you don't. Do people need more time? Okay, more people need more time than not. I'm going to give you all one more minute. Okay, I'll just give you one more minute. Reflection is important because it gives you a chance to put your lesson in context. You can think about it, compare to things you've done before. I'll unfold the slides. All right, welcome back, team. Patience in this matter has been very much appreciated. We are now going to go and take a quiz. So, again, here's how you're going to go take the quiz. It's going to be very exciting. All right? I'm going to show you the application share, how to get to the quiz. It's going to be a lot of fun. So, I'm going to take you to a very familiar looking screen. Okay? You log in to your class. Okay? We're going to kind of do this slow just so that I make sure everybody gets there. Okay? So right now, many of you are already logged in. In fact, all of you probably should be. So that's great. Your screen looks like this. I'm just going to show you the fast way to get there. So if you are getting there via the schedule and you have lots of missing assignments, that's totally okay. We're just going to go a different way to get there this time, okay? So I'm going to go to classes. Here's a friendly reminder, okay? Okay. If you haven't taken a unit assessment yet, You definitely should. So please go and do that. Okay? These are your classes. Remember, you want to click on these classes every day. Go into them and do some work. Okay? Your classes are different than my classes, I'm sure. However, you want to go into your classes every day and make sure you're completing some task in class. Every day there's something to do in each of your classes. It might take 5 minutes, it might take 30. Absolutely, Sarah, yes, you can still do Unit 1. Unit 1 will probably be open for the rest of the week. What's up, Chris? Yes, Christopher, your teachers are the ones you should talk to about that. You weren't here for any of this. Okay, Jenna, here. Jenna, send me a private chat, or Miss Ward. I think we can answer the question better in there. What quiz we have to do, I'm going to show you right now. Unit 1 stays open. However, at the end of the week, you won't be able to take the weekly quizzes or the unit test anymore. So please make sure you take it before then. Okay? Having said that, we're going to the class. You're in geometry. Again, your page looks a little different than this. However, this part's still the same. Actually, I'm just going to log in as somebody. Any volunteers for me to be you? Okay, Tyler Booth, you are the winner. Okay. Okay, so you're going to go to the progress button. You're going to go to quizzes. If you scroll down to Unit 2, it's the first quiz right here. Okay? There are other ways to get there, though. Okay? You can go to the Plan tab at the top of the page as well. If you go to Plan, it will take you to a page with a calendar on it. Okay? And right here in pink are all of your math class assignments. So if you click on this pink assignment for today and you hit More, it will take you right to 2.01, the assignment of the day. Okay? This lesson is the lesson that we just taught. My advice to you is this. Start by taking the quiz. All the extra credit quizzes are 5 questions long. If you get 4 or 5 correct, then you get the extra credit. So take the quiz right now. Like I'm going to put a timer up for 10 minutes for you to take the quiz. If you don't get if you don't get the extra credit, then go back through the lesson. Go back and click through these, and then take it again, because you can take it twice. Okay? So I'm going to put those steps in the chat. Take the quiz. Go do it now. Good luck. Click this button. Take the quiz. When you are done taking the quiz, give a screen check. Andrew, again, you want to go, when you're logged in, you're going to go to Classes, and then once you're in your class, you're going to hit the Plan tab. So I'll show you the whole process. Okay? You log in to your screen with the butterflies on it, or the dragonfly. Then you hit Classes. You click on this class, which is Math 202A Geometry. You click on that. Then you go to the Plan tab on the top of your screen. You hit Plan. And once you hit the plan, today's assignments come up. You're going to click where it says 2.01 Reasoning, Arguments and Proof Part 1. Then you hit More, and it will take you right to the lesson. If you scroll all the way down to the bottom of the page, the very last option is 2.01 Quiz, Reasoning, Arguments and Proof Part 1. Click on that, and it will take you to the quiz. Right? Okay, now here's the awesome thing for those of you who aren't taking it yet. See how I can log on as you, and I can see right here it says Attempt 1 in progress. I know and I can see that Tyler Booth, good job Tyler Booth, is taking the quiz right now. He's doing what we asked him to do. So, please take the quiz. We know if you're doing it or not. It tells us on our computer screens. Oh, 2.01. Okay. Sarah Bell, it's only 5 questions. It's literally 5 questions long. You can do it. You got this. %80 or better. Okay. All right. Dylan, if you failed hard, here's what you do. Go back to the lessons that are above it, read through the lessons, and then take it again. Make sure, did you take notes on the information presented today? Am I a terrible teacher? Why do you think it went wrong? Like, what questions were hard for you? Okay. All right. Well, thank you for your honesty. How can we fix it? Okay. Go back through the lesson. It's still in the same place. You go to the calendar, plan pad. The lesson is right above the quiz. So read through those, take notes on those. Maybe it's more helpful if you can see more of it in front of you, and then try to take it again. No, thank you. This is your exit ticket. Taking the quiz. Yes. What that means is, if you take this quiz today, you will get, it will count as you being in class. You will get those attendance points if you take the quiz today. So, go take it. Yes, Jaden, if you have taken the quiz, you can go. That's why I was asking for green checks to see who was done. Hey, green checks coming out of nowhere. Oh, we're going in on the green checks all of a sudden. Fans of that. Yes, but seriously, once you're done with the test, you can go. Or the quiz, I should say. You either, Chris. You either. It's going to be great. All right, team. Oh, okay. K12 appeared. All right, team. Please go take the quiz. I'm going to pick up the phone and see what's going on, and I will be right back.